Welcome to Einstein's mechanics, and today we are going to tackle the fundamental concepts in mechanics. This course is basic mechanics, and we are looking at the fundamental concepts. I am Brown, a mechanical 3 student, and I would like you to subscribe to the channel, and it's going to be interesting. So let's start with the fundamental concept in episode 1. Mechanics. So, mechanics is that branch of physical science which deals with the conditions of rest or motion of bodies under the action of what? Forces. So, in this definition, we saw that mechanics is a physical science. Yes, it's a physical science, meaning everything mechanics can be seen and touched. We deal with things like engines, shafts, and they are all physical, which deals with conditions. So you cannot just work with mechanical principles. You have to go by conditions. And when working on a body, the condition should be that the body is at rest or in motion. And the main focus of mechanics is we are going to look at the action of forces. We are interested in the forces acting on this body at rest or in motion. So let's bring this definition into physical aspect as mechanics suggests. So first, let's look at the body at rest. We can look at this figure. It's a block at rest. Let's say it's on the floor. And as we can see, this block is in equilibrium, meaning it is at rest. There is no movement, no rotation. And what makes this block at rest? Because all the forces are what? Balanced. Let's look at the action of forces. We have force 1, force 2, this is force 3, and the fourth force. And for this block to be at rest, all these forces must what? Balance. Let's look at the horizontal forces. We have this force as force 1 should be P. Let's name it P. For this block to be at rest, there should be an equal force P here to keep it what? At rest horizontally. The same thing if this 4 and 3 wants to keep this block in equilibrium without any vertical movement, let's name this W. This same force should be that so that they can all cancel out to make this block be in equilibrium. So at rest, this block can only be at rest if the summation of the horizontal forces is 0 and the summation of the vertical forces should be what? 0. Are we good? And this block will be at rest. But a situation where this force is P plus any one, this block will not be in equilibrium. There will be motion this way because this force now will be greater than the P. To keep it in equilibrium, we must add plus 1 here to keep it in equilibrium. If this force W is plus 1 here, it is no longer in equilibrium because there is going to be what? Movement downwards. Because the force applied downwards would be greater than the upward forces. So to keep it in equilibrium, this should be plus 1 so that the summation of the forces will be 0. You'll be asking how does the summation sum up to 0? So let's assume this force to be P. This force should be P. So I can say this force P, I'm choosing this side to be positive on and all forces this way should be negative. So this P plus a negative force should be 0 and the condition is what? Satisfied. So for a body should be at rest, we should know that the condition to make it happen is that the forces acting on it horizontally must sum up to 0 and vertically must sum up to what? 0. And this block satisfy that condition. So let's look at motion. We are dealing with a body in motion and we want to look at the action of forces on such body. We can look at this figure, a car. let's forget about the dimensions. We will use it later. But if this car is to be analyzed mechanically and we want to look at the action of forces on this car, first it is in motion, all right, and we are taking it at a particular point. So at a particular point we can get it stationary and we can make analysis as it is what moving. So if we are considering these wheels of the car on the floor, there is going to be a reaction force upwards to oppose the weight. So this is a reaction one. The same thing happens here, a reaction force R2, and we are going to have friction. We know that friction opposes the motion of what? Or opposes most motion. And this car is in motion, so there's going to be friction, F1, and the same thing here, F2. So have you seen the forces acting on this moving body? The weight of the car always act at the center of gravity, which is located here, G. So there's going to be the weight of the car downwards. Let's call it W. So we can see the forces acting on the car. We can forget about the shafts rotation and the engine actions, but if we are to look at forces acting on this car, this is these are forces acting on the car to keep it what? In equilibrium. And this car will be in motion until it is being acted upon by what? Another external force to keep it what? Stationary. That we will look at it in the next episode. So mechanical mainly depends on what? The conditions of rest and in motion. Why do we look at that? We want to look at the action of forces that is causing that rotation, that is causing that motion, or that is making the body to be at rest. And to make sure we get all these answers, we must look at the forces acting on the particular body. And we saw it as in case 1 and as in case 2. Classifications of mechanics. Yes, mechanics is classified into 3 branches. Yes, so that it can be what? Easily studied. And the first classification, we classify materials or mechanics into 1, rigid body mechanics. Rigid body mechanics. So when do we say a body is rigid? A body is said to be rigid if the particles remain at fixed distances from one another before and after the application of a load. Let's bring it physically. This is a bar. So this is bar 1. And we are applying forces F1 and F2, a compressive force. We are trying to compress this bar to reduce its what? Its length or the width. And mechanics, that is rigid body mechanics, is saying that after the application of this force 1 and this force 2, so F2 and F1, the distances or the particles of this bar from one another before and after the application of the force remains the same, meaning there's no deformation. That's the size and the shape of the body remains constant. There's no deformation. So we can show working here. Let's consider this block. And if I apply a compressive force like this, I have a force P and a force P. So P1, this is P1. Rigid body mechanics is saying that if I apply these forces to this block, and later I remove the forces, I should get this block intact. There should be no deformation. We can see that the same block is here, meaning this block is what? A rigid body block. It's a rigid what? Body. So the forces applied should not affect the size and the shape of the body. The same thing applies to this B. The force was applied at the ends of the bar, but after the forces were removed, we saw that this bar was not what changed in terms of size and shape. And all materials which behave such way are classified as what? Rigid body mechanics. So the second classification is mechanics of deformable bodies. As the name suggests, deformable, meaning these bodies can deform. When a force is applied and it is removed, the shape and size does not does not remain the same. There is either an increase in size or length or width, depending on how the application of the force was, or there's a decrease in size, in length, and in width, depending on the application of the body or the force on the body. So we can look at this body. So let's say this is a body and a force F1 is applied on the body. We can see this was a perfect circular body, but as the force is being applied, it is going to what change from the perfect shape it was to a deformable shape. So after the force F1 is removed, we can see that this body will no longer return to its original body. If it was circular, now if this force is removed, this body will not attain its perfect what? Shape. Therefore, it is classified to be a deformable body. The same thing can apply here. If I have this body and I apply a compressive force here, let's say F1, and I'm trying to compress this body, F2. If this body is deformable, if it is deformable, then after the application of these two forces, the body will not look exactly the same. Let's look at it. Now the body is going to be something like this. So it is deformed. When these forces were removed, this is the block now. It is deformed. And such bodies that changes size and shape when a force is applied on them are classified as what? Deformable bodies. And they're all under the mechanics of what? Deformable bodies. Mechanics of fluid, yes, it's very interesting. So we will also look at fluids and how they deform under the action of what? Stress. That shear what? Stress. And as we go forward, we will know how the mechanics of fluid also works. So basically, these are the three divisions of what? Mechanics. You have to get them once and for all. Rigid bodies, bodies which are not deformed, change in size when and after a load is being what? Applied. And two, deformable bodies, bodies that deform, change in size when a body undergoes what? Compression or tension force when a force is being applied on them. And mechanics of what? Fluid. We will look at how fluids change in size and shape when the shear stress is what? Acting on them. Now, idealization of mechanics from the word idea. Let's get some idea of mechanics. It's interesting. So we have some points we are going to discuss about to understand anytime we meet such words in mechanics. In mechanics. So the first one is a particle. A particle. In mechanics, we'll be hearing of the word a particle. And what's a particle? So a particle is a portion of matter so small that it may be regarded as a geometric point. We should know that a particle has mass but no size. So sometimes we want to make analysis of bodies and taking the whole body is very cumbersome. So we need a particle, a portion of it to make the analysis. And that portion we are going to take is called a particle. And it should be a portion of any matter that is under study. And it should be so small that it may be regarded as a geometric point. So it does not always mean that the particle is very small. We can consider a human being as a particle depending on what? The matter under consideration. For example, if we want to study anything about the earth and we take a particular city as a particle, yes, comparing as we compare the size of a city to the entire earth, that city can be what? A particle, because it's so small that it may be regarded as a point. So the analysis can be made. The same thing, a particle can be what? A human being, depending on the matter and the study. So for example, I like using blocks like this, and I want to study the behavior of forces. So this is force 1. The same thing here, force 1. Another tension force, force 2, should be opposed by another force 2. I want to study how this block is going to survive on the influence of these forces. And I want to know how. Maybe I cannot work with the entire block and I want to take a portion. I can just take a portion of it so that I get this portion to study and get the entire effect of the forces on this block. So this portion and the study that I've taken from this matter, which is so small that it can be regarded as a point, is now what? My particle. It's quite interesting. So if I want to work on anything and I take a small portion to make analysis, that portion is considered to be what? A particle. I hope you get it. Real bodies. So an idea that we have to also get is real bodies. What are real bodies? In mechanics, real bodies are never what? Perfectly rigid. They deform when subjected. So they deform when subjected to what? Forces. So we can say that anybody that deforms when it is subjected to force is called a real body. So a real body is a body that deforms when subjected. So when subjected to force or forces, and that body is termed to be a real body. A point force. Point force. In mechanics, we are going to meet many problems regarding to point force. And what is a point force? A point force is a finite force that is assumed to be transmitted through a small area or point. So when we look at a body, let's consider this diagram. We are considering this diagram. And if this is a point force. We want to understand what a point force is. And we are saying that it is a finite force that is assumed to be transmitted through a small area. Or a point force, these are forces acting on what? A particle or a single point. They are assumed to be transmitted at a point. So I have F1, F2, F3, and their effect is acting on a single point. That type of force or that action is called what? A point force. So if I trace this here, the line of action and this force, all these forces, they are meeting this place. And I can call this region as what? As a point force. So forces acting at a single point are called point force. So let me do this, and I have a force acting here, another force acting, another force acting, and another force acting. All these forces acting on a particle, this becomes a point or they're acting at a point, a particular point. And it's interesting. It helps us to understand what mechanical ideas or mechanical problems. We get how to what resolve them and get our answers. How to replace them by what a resultant force or a single force to produce the same effect. We will discuss such problems in the next slides. So let's look at perfectly elastic body. Elastic. They are perfectly elastic. In mechanics, as we are moving forward, we hear anything perfectly elastic body. What does it mean? As the name suggests, elastic. So a body is said to be elastic when it retains its original shape and what size when a load or a force is applied and removed in simple terms. So let's look at this. As a person is trying to compress this ball, and if he or she tries to what stop the action of the force being compressive, this is a compressive. The person is trying to compress the ball. And if the action is stopped, the ball regains its original what? Size. And such bodies are called perfectly elastic. So if you are working on any mechanical problem and you hear the body is perfectly elastic, meaning it's going to regain its size and shape when the force being applied is removed. And it helps us to analyze certain structures and come out with what? Solution. It's very interesting, and I hope we are getting these ideas. There are a lot of ideas that we could talk about, something like the continuum assumption, perfectly elastic body. Yeah, we talked about perfectly elastic, frictionless fluids. They are all idealization of what? Mechanics. And we need these ideas to what? To help us in our basic mechanics course, and it's going to be interesting. Thank you for watching this episode, and I hope you like the explanation. Let's watch out for the episode 2, and we are going to talk about the Newton laws and solve examples on them. It's going to be interesting. I am Ade Brown. Thank you. Subscribe to the channel and see you later.